What my company, Magnum Consulting Services, does is I help clients who may have the Maxwell software and they are so busy that they don't have the time to devote to work on projects. I've done alternators for Harley-Davidson, or DC machines for P&H mining, or magnetic actuators, which have an armature that move up and down and determine, say, the force versus stroke on the armature. Harley-Davidson had to design a new alternator that had more output. So instead of building all these different prototypes that would take a long time to build and test, they said, here are the parameters, here are the constraints on the model. You come up with an alternator and develop a model so that we can get X amount of current out of that alternator. It saves an enormous amount of time and money from building prototypes and testing. So I can make rapid changes, maybe change the permanent magnet material, the air gaps, the winding information, and then look at the outputs very quickly in a matter of hours or days. Last year I worked on a project for P&H mining. They have huge shovels. They're as big as this room, and they have a DC machine on the shovel that's very big. It's about 5 feet in diameter by about 6 feet long. It's just an enormous machine. And they wanted to change some of the windings, the geometry of the rotor, and see how that DC machine would perform. Because to build one of these would take a very long time, maybe months, and then to test it, would be another whole process. So it saved them lots of time and money to do the computer simulation. I believe that most directors of engineering do know the value of using computer models, and they know that if you can predict how an actuator, say, will behave, it will save them time and money because they could do the design on the computer rather than in the lab. There are other electromagnetic finite element software packages out there, but I feel in the years that I've been doing this that Ansys has the Cadillac on the market.